we begin today's event, we'd like to kindly remind all participants in this room to make yourself comfortable and prepare your notes. For our online participant, please change your display name into university_name. And don't forget to turn on your cameras. Use the virtual backgrounds provided by the committee. Thank you.
Technologist Dr. Muhammad Azmi bin Patar. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya. Greeting of kindness. Good afternoon and peace to us all. First of all, we like to thank and appreciate for those of who has leisure your time to attend this event. My name is Gozi and
My name is Altaya.
We will be the master of ceremony today's event. A perfect evening, and may we extend a warm welcome to the Honorable Department Head of Instrumentation Engineering, Dr. Senior Toto Suhartanto, DEA. The Honorable to our lecture in Instrumentation Engineering. And the Honorable and amazing speaker for today's webinar, Thermodynamics and Control Engineering, Technologist Dr. Muhammad Nur Azmi bin Patar. And heart a welcome to all participants join us today. Ladies and gentlemen, welcome to webinar Thermodynamics and Control Engineering.
Hi everyone, how are you today? We hope you are having a great day. To start the opening of this event, I would like to read the rules of procedure and the agendas for today's event. The first is opening ceremony, and the second is national anthem and ITS hymn, and then the third is opening speech by the head of the Instrumentation Engineering Department, and then the fourth is presentation by material by the speaker, and then the fifth is question and answer session, and the sixth is documentation and closing ceremony. I hope you will enjoy it. Okay, ladies and gentlemen.
The first agenda to all the participants. As we are going to play in the Indonesia national anthem, we will be followed by ITS hymn. Please stand up and silent. For who in Zoom meeting, please kindly turn on your camera and mute your microphone.
Thank you for the operator for the display, and thank you to all of the meeting participants for the cooperation. Please sit. And now, is it my pleasure to welcome and invite Dr. Insinyur Toto Suhartanto, DA, to deliver an opening speech. For Dr. Insinyur Toto Suhartanto, DA, the time is yours.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera. You are welcome, Bapak Dr. Muhammad Nur Aziz, to our department. This is Department of Information Engineering, one of 8 department in vocational faculty. Our department originally from engineering physics, so our basic is physical applied. So that way, in this day, I hope you can explain to our student how to design the system for measurement, for control, to get the stability of plant. One of this is a thermodynamic system, because I learned mechanical, electrical, process, chemical. So we must know the character of the process. It's my uniquely our department. And I hope our student, you can ask to Bapak Dr. Muhammad Nur Aziz if you have a question. And hope this event, we can started our collaboration between ITS in University of Mara, gitu ya, about student exchange or research exchange. And I hope if any possibility scholarship gitu from for master or for doctor, I wait your information. Okay, thank you very much for Bu
Recording
Putri,
in progress.
And the team for this session. Okay, I hope this event will be in a good session. Okay, thank you very much again for Bapak Dr. Muhammad Aziz for your coming, and insya Allah give you a pahala. Okay, thank you very much. Akhirul kalam, wassalamualaikum warahmatullahi wabarakatuh.
Thank you for Dr. Insinyur Toto Suhartanto, DA, for the wonderful speech. And now, for the next session, will be conducted by our moderator, Mr. Radhy. Hello, Mr. Radhy. How are you today?
Hello, I'm fine.
Okay. Are you excited about this event now? Are you excited?
Yes, of course, yes.
So, are you ready for being moderator?
Yes, I'm going to be moderator today.
Okay. So, since Mr. Radhy, our moderator is ready, then Mr. Radhy, the time is yours. Thank you.
Okay, thank you, MC. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, all of the students attending this international webinar. Okay, today we have keynote speaker, Dr. Mohd Nur Azmi, from from Faculty of Mechanical Engineering, Universiti Teknologi Mara. And then today our activity is the International Lecture Series of Instrumentation Engineering Department, the Thermodynamics and Control Engineering. Okay, this event is an international public lecture organized by the Measurement Instrumentation Laboratory, Department of Instrumentation Engineering. And today we have target participant of the student in instrumentation department, and then we have 16 minutes to presentation, and 45 minutes for exposure, and then uh, 15 menit for discussion. Okay, and then in total we have 90 minutes. Okay, I hope our student will enjoy this event. And then now we please Dr. Mohd Azmi to present about the thermodynamic and the control engineering. Okay, we can begin now. Okay.
Hello, testing. Okay, Assalamualaikum. And very good afternoon. Do you hear my voice? Okay. Okay. Okay, my name, before we proceed further, I would like to introduce myself again. Okay, my name is Muhammad Nur Azmi bin Abdul Patar from Universiti Teknologi Mara. You know Malaysia? Yes. Okay. Yeah? Okay, I'm from Malaysia. Okay, today I would like to share with you about this interesting topic about thermodynamic and control engineering. Okay. Okay. Next. Okay. A little bit about myself. Currently, I'm a senior lecturer at this university, at Universiti Teknologi Mara. Okay. Before this, I pursue my study from bachelor, master degree, and PhD in Shibaura Institute of Technology, Japan. Okay. After that, I have a little bit experience in instrumentation engineer in Japanese company. Okay. In Malaysia. Okay. My research area mainly about rehabilitation engineering, biomechanics, biomechatronics, robotics, and biomaterial. Okay, this is a presentation outline. Okay, we have two parts. Okay, about first part we will cover. First part we will cover about thermodynamic. Okay, and then part two we will cover about control engineering. Okay, so I think this is mostly about the introduction to thermodynamic and control engineering. Okay. Okay. Do you know what is a thermodynamic? Uh, any idea? Can you give briefly about thermodynamic? Okay. Actually, thermodynamic is a word from thermal and dynamic. Okay. Haba dan pergerakan haba. Heat transfer. Okay, it's about relationship between heat, haba, kerja, works, temperature dan juga energy. Okay, so thermodynamic adalah related dengan transfer energy. Okay, di mana energy ni boleh berubah. Okay, can be transformed from one to another energy. For example, energy can be potential energy, kinetic energy, and so on. Okay, so more simple definition about thermodynamic is thermodynamics is can convert heat to work or vice versa, work to heat. Okay, so if you can see in this figure, okay, so chemical from chemical energy, okay, there is a storage energy. Okay, it's transfer. So chemical energy transfer to engine, and then in the engine, we have a chemical reaction, combustion, and it's convert the chemical energy into heat energy, okay, through the combustion process and so on. So heat energy then converted into work or power and kinetic energy through engine mechanism. Okay, the motion of engine makes kinetic and so on. Okay, so part of heat energy is disposed in the atmosphere as a waste. Okay, so it means that energy can be converted to another form. Okay, and then this is another introduction about thermodynamics. So energy is stored and transferred within a body. Okay, energy transformation mostly involve heat, work, and mass flow. These three important parameter. Okay, haba dan juga kerja boleh di tukar ganti, interchangeable. Okay, this is another example related to energy conversion system. Okay, antaranya adalah reciprocating engine. Okay, in the area of automotive engine. Okay, there are a lot of example here like steam engine, gas turbine engine, air conditioning, and so on. Okay, so energy. Okay, energy adalah ability to cause change. Okay, energy kita tidak boleh nampak, abstract, invisible. Okay, but it does not exist in physical form. Then it exists in other physical substance. For example, here you can see heat exists in fire. So we can feel the hot of fire. And the work exists in moving object. We can see object is moving, okay, from one location to another. And the mass flow exists in other physical substance. Mass flow exists in fluid flow. You can see also the fluid flow. Okay, basically there are two types of energy. Okay, you can see here we have microscopic energy and macroscopic energy. Okay, microscopic more on molecular structure, it's very small. Okay, so this energy is more on the molecular activity and they are independent or outside reference frame. Okay, okay, mostly microscopic energy is about the internal energy. Okay, it's very small compared to microscopic energy. Okay, micro level and macro level is more bigger than microscopic energy level. Okay, so these two group of energy, okay, masing-masing ada kinetic energy dan juga potential energy. Okay, tapi berbeza level kekuatan dia. Okay, microscopic adalah energi yang kecil dalam bentuk molekul, okay, molekul activity. Manakala yang macroscopic energy ni adalah energi yang besar yang boleh menggerakkan suatu mekanisme. Okay, kalau tengok di example gambar rajah ni, kita boleh lihat microscopic energy untuk cecair ini adalah melibatkan pergerakan molekul. Okay, pergerakan molekul. So sekiranya kita menekan dia punya cecair ni, dia akan menggerakkan mengaktifkan dia punya pergerakan molekul. Jadi perbezaan dekat sini, daya tekanan yang kita bagi dekat cecair ni adalah dalam bentuk microscopic energy, energi yang besar yang boleh menyebabkan dia punya bentuk ataupun isi padu dia berubah. Okay. So kalau tengok dari segi pergerakan motosikal pula, dia punya energi, micro energy ataupun internal energy adalah daripada pergerakan mekanisme engine. Itu adalah micro energy. Okay, yang menggerakkan motosikal ni adalah macro energy. Okay, energi yang lagi besar daripada internal energy tadilah. Okay, kalau tengok dari segi dia punya equation, okay, kita ada internal energy plus dengan macro energy. Okay, kinetic energy plus potential energy. Okay, dalam unit kilojoule. Alright. Okay, dari segi overview of thermodynamic energy concept. Okay, seperti bentuk energi yang besar. Okay, satu micro level energy yang menyimpan energi in storage. Manakala micro level adalah energi yang boleh menggerakkan sesuatu mekanisme tadilah. Okay. Dan example untuk micro energy adalah internal energy. Okay, it is a state property or a point function. Okay. Right. Kemudian kat sini ada 3 benda yang penting yang perlu kita tahu adalah mass flow, work transfer dan heat transfer. Okay, di bawah work transfer ada 2 elemen yang penting, iaitu mechanical form of work transfer dan non-mechanical form of work transfer. Okay, nanti kita akan lihat dengan lebih detail kemudian. Okay, di bawah mechanical work transfer, example dia adalah pedal wheel work. Okay, dan compressing work. Okay, manakala non-mechanical adalah melibatkan electrical work. Okay, the force is the voltage, the electrical potential, displacement is the electric charge. Okay, itu secara overview dalam thermodynamic lah. Okay, so dalam thermodynamic ni ada 4 laws yang sangat penting. Okay, mana dia ada zeroth law, first law of thermodynamic, second law dan third law. So apa di sebalik laws ini? Okay. Okay, untuk first law secara ringkas dia adalah lebih kepada temperature dan equilibrium, keadaan balance, equilibrium condition. Okay, untuk zeroth law, okay, two system in equilibrium will with a third system are in thermal equilibrium with each other. So kalau tengok dari segi gambar rajah ni, okay, kalau suhu rumah sama dengan suhu kereta, suhu kapal sama dengan suhu kereta. Jadi kita boleh combine dia punya relation dekat sini menjadi suhu rumah sama dengan suhu kapal. Ataupun dalam bentuk matematik dia, A equal to B, C equal to B dan A adalah equal to C. Okay, kita boleh tengok dia punya condition dekat situ. Okay, itu adalah zeroth law. Manakala first law, okay, peraturan yang pertama untuk thermodynamic adalah conversion of energy. Okay, energy can change form. Okay, energy boleh berubah bentuk tadilah. But is neither create nor destroy. Okay, itu adalah first law. Second law melibatkan heat transfer ataupun heat flow. Okay, heat flow daripada objek yang panas kepada objek yang sejuk. Okay, dia tidak boleh daripada sejuk kepada panas, dia satu direction sahaja. Okay, daripada panas kepada sejuk. Okay, manakala yang ketiga adalah entropy of a system approach a constant as temperature approach absolute zero. Okay, so kalau nanti kita akan lihat dengan lebih detail kemudian. Okay, so kita tengok balik zeroth law tadi. Okay, kita dah tengok zeroth law, adalah melibatkan temperature scale. Okay, lebih kepada calibration lah ni. Okay, bila kita nak melihat kita punya device, adakah bacaan yang dikeluar oleh sensor ataupun device yang ukuran kita, adakah betul, kita perlu membuat pembandingan. Okay, we need to compare the bacaan dia lah, measurement. Okay, contoh dekat sini, kita ada dua bekas air. Okay, bekas yang pertama A dan bekas yang kedua B. Okay, kemudian to spread cup of boiling water, sekiranya kita letak termometer ke dalam bekas A, kita akan dapati the mercury dalam termometer ni akan increase pada certain value, iaitu 100 degree C. Okay, kita akan dapat lihat pergerakan dia certain level dan dia akan stop pada 100 degree C. Okay, kemudian kalau kita letak temperature yang sama pada bekas B, kita akan dapati fenomena yang sama. Okay, di mana mercury rise to a certain level until 100 degree C. So fenomena seperti begini adalah thermal equilibrium. Okay, A and B adalah dalam keadaan thermal equilibrium. Okay, right. So next, first law tadi, okay, conservation energy. Okay, total energy kita ambil kira dalam isolated system. Okay, total energy adalah constant. Energy boleh berubah dari satu bentuk kepada bentuk yang lain. Okay, but can be neither created nor destroyed. Okay, kalau dari segi dia punya equation matematiknya adalah energy in minus dengan energy out adalah perbezaan energi kedua-dua tadilah. Okay. Okay, kalau kita tengok example yang tengah ni, okay, batu, kedudukan batu dekat atas bukit bila dia jatuh ke bawah, okay, berlaku perubahan daripada potential energy kepada kinetic energy. Okay. Okay, dari segi potential energy untuk yang kedudukan di atas adalah lebih tinggi. Maksimum potential energy 10 unit. Kemudian kat sini kita boleh nampak kinetic energy adalah 0. Okay, bila dia start bergerak, okay, potential energy akan jadi 7 unit dekat sini. Kinetic energy adalah 3 unit. Okay, kita boleh tengok dekat sini jumlah energy adalah sama. Okay, 7 plus 3 will become 10 unit. Okay, masih sama energy dia. Okay, itu salah satu contoh first law of thermodynamics. Okay, dan banyak lagi lah contoh dekat sini. Right, so second law of thermodynamics. Okay, pergerakan heat transfer tadi daripada objek yang panas kepada objek yang sejuk. Okay, dari segi fenomena yang okay. So second law of thermodynamics So secara based on observation, ada 3 konklusi yang kita boleh lihat dekat sini. Yang pertama, heat flow daripada high temperature kepada low temperature. Okay, yang kedua adalah different substances carry different amount of energy. Okay, different quality of heat carry different value of temperature. So daripada sini kita boleh relatekan dengan entropy. Okay, entropy adalah the ratio between the change of heat and equilibrium temperature. Okay, S adalah entropy equal to delta Q over T dalam unit Kelvin. Okay, kilojoule per Kelvin. Okay. Laws yang ketiga, okay, melibatkan entropy tadi. Okay, entropy of a perfect crystal is 0 when the temperature of the crystal is equal to absolute zero. Okay, so the crystal must be perfect. Crystal dalam bentuk solid. Okay, so or else there will be some inherent disorder. It also must be at 0 Kelvin, otherwise there will be thermal motion within the crystal which leads to disorder. So a consequence of the third law is it is impossible for any process, no matter how idealized, to reduce the entropy of a system to its absolute value, absolute zero value in a finite number of operation. Okay, in actuality, no object or system can have a temperature of 0 Kelvin. Okay, because of the second law of thermodynamics. Okay, the second law in part implies that heat can never spontaneously move from a colder body to a hotter body. So second law tadi adalah melibatkan heat transfer daripada objek yang panas kepada objek yang sejuk. Dia tidak boleh terbalik lah dia punya pergerakan heat transfer. Okay. Okay, kemudian kita lihat dekat sini kita ada istilah system, surrounding and boundary. Okay, dekat sini kita boleh nampak sistem, di luarnya adalah boundary dan di luar boundary adalah surrounding. Okay. So a thermodynamic system is a microscopic volume in space. Okay, that can be adequately described by thermodynamic state variable such as temperature, entropy, internal energy and pressure. Okay, system adalah quantity of matter or a region in space chosen for study. Okay, sistem adalah melibatkan suatu perkara dalam ruang lingkup yang study yang kita fokuskan. Okay, manakala surrounding adalah the mass or region outside the system. Okay, dan boundary adalah sempadan lah, sempadan sama ada real or imaginary surface that separate the system from its surrounding. Okay. So ni gambar rajah dia lah. Okay, kita ada sistem yang dash line adalah boundary. Okay, di luar boundary ada surrounding. Okay, so ni adalah example isolated boundary. Okay, dalam sistem ni kita ada 3 jenis sistem, iaitu isolated system, closed system dan open system. Okay, so secara detailnya adalah macam inilah dia punya gambar rajah. Example untuk isolated system adalah flask, okay, ataupun termos. Okay, dari segi dia punya pendetailan adalah kalau kita tengok dari segi gambar rajah dekat sini, untuk isolated system, energi ataupun matter ataupun mass tidak boleh masuk ataupun keluar daripada dia punya boundary tadi. Okay. Manakala closed system dia hanya membentangkan energi, keluar masuk energi sahaja. Metal ataupun mass tidak boleh keluar daripada boundary sistem, closed system. Okay, manakala open system, kalau kita tengok dekat sini, dia membenarkan keluar masuk energi dan juga keluar masuk mass tadi. Okay. Right. So ni adalah pendetailan dia lah. Okay, sama juga yang macam tadi. Okay, example dia adalah coffee in a closed well insulated thermos bottle. Okay, energi dan juga mass tidak boleh keluar masuk daripada boundary dia. Okay, next adalah example untuk closed system. Okay, closed system, kalau kita tengok yang tadi, mass dia adalah constant. Tidak berlaku perubahan mass lah. Energi boleh berubah dekat sini. Boleh berlaku energy in dan energy out. Okay. So closed system also known as control mass. Okay, dia adalah kita boleh control mass dalam bentuk constant value. Okay, next adalah control volume ataupun open system tadi. Okay, so open system dia membenarkan kemasukan mass dan juga energi. Okay, right. Okay, next dalam sistem ada dua okay, kita ada static dan juga dynamic system. Okay, dynamic berlaku system that change over time. Okay, dia melibatkan previous state dan juga external disturbance. Okay, external disturbance adalah gangguan luar ataupun noise yang mengganggu sistem dynamic system. Okay, so dynamic system have the ability to convert the value of input variable to the value of output variable. Okay, this is example of system. Kita ada dalam bentuk technical, motor engine, dan kita ada algorithm. Algorithm adalah satu bentuk sistem. Dan kita ada electrical circuit dan seterusnya. Selain daripada teknik ataupun dalam bentuk technical, kita ada juga sistem dalam bentuk biological. Okay, example kat sini kita ada cell, okay, water system dan juga sistem brain. Okay, next, properties of a system. Okay, property, any characteristic of a system. Okay, some familiar properties are pressure, temperature, volume and mass. Okay, ada dua bentuk properties dekat sini, iaitu intensive property dan extensive property. Okay, ada dua bentuk property lah yang perlu kita tahu. Okay, selain daripada itu, property of the system adalah specific property, extensive property per unit mass. Okay, volume per mass. Okay, ada example specific enthalpy dalam kilojoule per kilogram and so on lah. Okay, thermodynamic equilibrium, a system that maintain thermal uniform temperature, mechanical uniform pressure, phase, the mass of two phase, for example, ice, liquid, water in equilibrium and so on. Okay, there are state and equilibrium. What is state? Okay, state, a set of property that describe the condition of a system. Equilibrium adalah keadaan seimbang. Okay, okay, there are no unbalanced potential or driving force within the system. Okay, so next kita ada process and cycle. Okay, process adalah any exchange that a system undergo from one equilibrium state to another. Okay, Manakala path adalah series of state. Okay, kita ada banyak state dekat sini. Okay, bila dia kalau kita gabungkan semua bentuk state dekat sini, dia akan menjadi satu laluan lah. Okay, daripada S1 to S2, daripada initial state sampai final state, kita akan nampak dia punya proses path. Okay, dan seterusnya. Okay, so dekat sini adalah process diagram. Okay, plotted by employing thermodynamic properties as coordinate are very useful in visualizing the process. Okay, prefix. Okay, perkataan ISO adalah bermaksud remain constant or equal. Okay, dekat sini banyak istilah dia. Isothermal adalah melibatkan temperature remain constant. Isobaric adalah proses di mana pressure adalah constant dan seterusnya lah. Okay. Okay, dekat sini kita ada istilah steady state flow process. Okay, steady bermaksud no change with time. Opposite dia adalah unsteady ataupun transient. Okay. So di dalam application thermodynamic dekat sini kita boleh nampak applicationnya dalam kita punya peti sejuk dan sebagainya lah. Okay, next kita continue dengan part kedua, iaitu related dengan control engineering. Okay, kat sini kita akan lihat beberapa informasi ataupun istilah yang penting untuk control engineering. Okay. Okay, first kali kalau kita tengok gambar rajah ni, apa yang awak nampak dengan gambar rajah proses ni? Okay, ada yang boleh bagi idea apa yang kamu lihat daripada gambar rajah ni? Any idea? No idea. No idea. Okay, thank you. Do you have any idea?
The control is the picture is manual.
Manual control.
Manual control.
Okay, thank you. Any idea?
I think I have idea same with my friend. It's manual control.
Oh, manual control.
Manual control.
Okay. Other idea? Do you have other than this idea? Okay. Actually, this figure show about the process control in factory. Okay, if you see on the right, on the left side is sensor. So when sensor measure a temperature, it will transmit the information to his friend. Okay, his friend is transmitter. Okay, and then his friend will transmit the information that he get to his boss here. Okay, so boss as a controller, central controller, will instruct his worker. Okay, okay, dia akan bagi arahan kepada pekerja dia untuk memastikan temperature yang ada dekat sini adalah sama seperti yang dia mahukan. Okay, so there are the desired, okay, desired temperature value that their factory needs to follow. Okay, so the information here, okay, before the valve as actuator move to the certain level of value, there needs a confirmation from the value potentiometer. Okay, so when the value potentiometer give instruction here, so actuator will move accordingly. Okay, this example is a control process. Okay, so as we know, there are uh, industrial revolution in our world. So firstly, we have industrial 1.0, okay, yang melibatkan mechanization, water power, steam power and so on. Okay, kebanyakan industri pada ketika ini menggunakan teknologi steam power. Okay. So kalau kita tengok sedikit video dekat sini. So ni adalah steam watt steam engine lah. Okay, kita boleh lihat dekat sini pada waktu tu kegunaan watt steam engine sangat meluas di peringkat factory lah. Okay, so fokus dia adalah untuk production dan seterusnya pada industrial revolution 2.0 lebih kepada mass production, okay, assembly line, require labor and electrical energy. Pada revolution 3.0 lebih kepada automated production using electronic, robot and IT lah. Okay, automation. Kemudian sekarang ni melibatkan intelligent production, melibatkan communication antara machine. Okay, so kita boleh lihat dekat industri di Jerman. Okay, kalau kita tengok dekat sini dia punya industri 4.0 telah digunakan secara meluas lah. Okay. Okay, definition and basic concept in control engineering. Okay, dekat sini kita boleh lihat example untuk control system. Salah satunya adalah a person balancing on one foot. Okay. Kemudian kita ada example untuk M.Si guidance system dan juga single joint robotic arm. Okay, generally a control system is characterized by input controller generating and command to a plant ataupun proses. Okay, dalam sistem ni kita ada input, controller, plant dan juga output. Okay, dari segi gambar rajah block diagram, kita boleh lihat dekat sini kita ada input ataupun reference. Okay, kita kena ada parameter yang kita hendak control ataupun desired parameter dekat sini. Okay, kemudian controller akan bagi generate the command to the plant ataupun process. So daripada proses dia akan keluar output ataupun control variable. Okay, yang ni adalah basic control system. Okay, another example dekat sini kalau kita lihat adalah pemanduan kereta dalam kelajuan tertentu. Okay, bila dia punya desired speed, kita set desired speed dan user akan tekan throttle. Okay, throttle. Kemudian throttle akan bagi maklumat kepada plan ataupun proses tadi, di mana berlaku dekat engine, dan seterusnya dia akan transmit data kepada vehicle, kenderaan tersebut. Dan output dia adalah actual speed. Okay, kat sini kita ada dua parameter, input dan output. Cuma untuk case ni, dia tidak ada measurement antara desired speed dan juga actual speed. Tidak berlaku comparison bacaan dia. Okay, kemudian example yang kedua, kita ada desired cooling. Okay, untuk menyejukkan suatu bilik, kita memerlukan kipas angin. Okay, so bila controller dekat sini sebagai switch, okay, ditekan dan dia akan transmit electrical power kepada proses dia ataupun plant tersebut ataupun sistem tadilah, dan menghasilkan suatu output. Untuk case ni adalah actual cooling. Okay, ni another example. Okay, so dari segi istilah control engineering ni ada beberapa istilah yang penting lah. Okay, antaranya adalah sistem tadi. Okay, sistem adalah kombinasi komponen that add together and perform a certain objective. Manakala control variable tadi adalah the quantity ataupun kondisi that is measure and control. Okay, manakala okay, dan kita ada the control signal ataupun manipulated variable. Okay, the quantity or condition that is varies by the controller so as to affect the value of control variable. Okay, kemudian kita ada plant ataupun sistem tadi. Okay, it can be a piece of equipment, perhaps just a set of machine part and so on. Okay, manakala proses adalah a natural, progressively continuing operation or development marked by a series of gradual changes that succeed one another and lead towards end. Okay, ini adalah istilah yang perlu kita fahami yang sering kali digunakan dalam control engineering. Okay, kemudian kita ada satu lagi istilah iaitu disturbance. Okay, ataupun external noise daripada luar yang mengganggu sistem yang kita ada lah. Okay, tadi kita dah tengok input, output, kemudian kita ada external disturbance ataupun input luar. Okay, a signal which tend to affect the value of the output of the system. Okay, another example kat sini adalah feedback control. Okay, feedback control adalah an operation that in the presence of disturbance tend to reduce the difference between the output of a system and some reference input. Okay, contohnya dekat sini adalah watt speed governor. Okay, kalau kita tengok dekat sini, dia punya mekanisme adalah, okay, kita tengok example. Okay, example dia, pergerakan dia macam ni lah. Okay, so kalau kita bagi pada high load, okay, pergerakan speed putaran dia akan jadi lambat lah. Okay, kalau low load, dia akan speed dia rotate dalam kelajuan yang tinggi. Okay, so bila kita tekan dia punya mekanisme dekat sini, so dia akan menyebabkan spring ni tertolak, okay, dan dia akan berputar lah mengikut load yang kita bagi dekat sini lah. Okay, right. So ini sama juga.
If a diesel engine is to be operated within a certain speed range and under varying loads, a mechanical device is required to control the amount of fuel injected. This device is called a governor. The speed of a diesel engine depends on two factors: the amount of fuel injected into the cylinders and the load under which the engine works. Suppose, for example, that the engine is running at a certain speed. If the load is increased, the engine slows down. If, on the other hand, the load should decrease with no change in the amount of fuel injected, the engine speeds up. By regulating the amount of fuel injected, the engine speed may be kept within a certain range. To do this, various types of governors have been developed. Most governors operate on the principle of centrifugal force. Centrifugal force is the tendency of an object, when traveling in a circular path, to move away from its axis of rotation. These rotating weights are affected by this force. As the speed is increased, centrifugal force grows stronger, pushing the weights further away from their rotational axis. The distance from this axis is proportional to the speed of rotation.
Okay, itu adalah macam mana pergerakan warp speed governor tadi. Okay, dekat sini kita boleh identify, okay, plan tadi adalah engine dia. Okay, manakala control variable adalah speed of the engine. Okay, control signal adalah amount of fuel to be applied to the engine, and there is a error signal. Okay, the difference between the desired speed and actual speed. Okay, manakala disturbance tadi adalah unexpected change in the load. Okay, so setiap sistem kita kena identify mengikut istilah yang tadi lah. Okay, dekat mana dia punya plan, control variable dia apa dan seterusnya lah. Okay, so selain daripada technical mechanism, okay, sistem juga ada dekat biological system lah. Okay, contohnya body manusia. Okay, so control system dia ada dua jenis, iaitu without a feedback. Without feedback yang tadi lah, yang kita tengok straight line, tak ada measurement antara output dengan input. Okay, with feedback ni ada dua jenis, iaitu positive feedback dan negative feedback. Okay. Okay, tujuan dia adalah untuk memastikan equilibrium tadi. Okay, dalam biologi, equilibrium dia kita panggil homeostasis. Okay, sama je dia punya konsep. Okay, untuk sistem tadi yang kita lihat adalah open loop system. Okay, dia adalah tanpa feedback lah. Okay, no information reach the control unit. Okay, tak ada measurement yang dilakukan antara output dengan input. Okay, example-nya adalah automatic washing machine ataupun heater ataupun traffic light. Dia tidak ada sensor yang membuat measurement antara bacaan dekat output dengan bacaan input. Okay, yang kedua kita ada tadi negative feedback. Tadi without feedback. Sekarang ni kalau ada feedback, kita akan letakkan sensor lah. Okay, sensor untuk mengukur bacaan output dengan input value. Okay. So feedback ni dia ada dua jenis. Okay, positive feedback, positif, simbol dia positif dekat sini lah. Okay. Dia akan melihat dekat sini positif ataupun growth. Okay. Kalau satu lagi adalah negatif, negative feedback. Okay, negative feedback. Okay, perbezaan dia kalau negative feedback ni dia akan menyebabkan sistem kita slow down ataupun complete stop apabila bacaan output dengan input ni sama, dia akan stop. Kalau yang ni dia terbalik lah. Okay, dia akan semakin bertambah. Okay, right. Okay, example dia dekat sini. Untuk negative feedback adalah proses sweating. Okay, berpeluh. Okay, contohnya macam ni lah. Okay, sekiranya body yang ni, sekiranya kita menggigil, okay, menggigil maksudnya heating mechanism activated, okay, shivering. Lepas tu body temperature akan increase, okay, dan cooling kalau waktu berpeluh, okay, body temperature, cooling mechanism akan activated lah. For 5 minutes, okay. So this is example of open loop system. Open loop system is a control system which the output has no effect to the control action. Okay, yang ni tak ada measurement dekat antara input dengan output. Manakala closed loop system adalah ada sensor, okay, yang kita measure menggunakan sensor tadilah. Okay, so this is open loop. Closed loop adalah macam ni dia punya block diagram. Okay, so control system are required in complex machine device, for example, aircraft control system, anti-lock braking system, and so on. Okay, so control engineering application sangat meluas. Okay, bukan sahaja mechanical, kita ada electrical, chemical, aerospace, civil, mechatronic, environment, and so on. Dan ada juga aplikasinya dekat non-engineer. Okay, example-nya adalah dalam bentuk ekonomi, bidang ekonomi. Okay, contohnya dekat sini input value dia adalah untuk control inflasi. Okay, jadi controller dekat sini adalah government, governor of the bank. Kemudian proses dia berlaku dekat ekonomi negara. Kemudian sensor dekat sini adalah ekonomis. Dia akan membuat pembandingan actual inflation dengan targeted inflasi. Okay, ini adalah satu example dalam bidang ekonomi. Okay, jadi dekat sini kita kena identify lah apa dia plan dia dekat mana, sensor apa dia, controller apa dia. Okay, sama juga untuk water level control in a toilet tank. Jadi kita kena identify dia punya apa dia plan, sensor, controller, and so on. Okay. Jadi setiap sistem kita kena identify dia punya control element dalam ni. Okay, untuk case ni plan adalah dekat water tank, sensor adalah float bore, controller adalah ball cork and overflow tube. Okay. Ni adalah example untuk yang ada disturbance. Okay, disturbance adalah gangguan external noise daripada luar. Okay. Right. So example dekat sini untuk water level control dia ada dua kebarangkalian yang kita boleh okay, dekat sini ada open loop dan closed loop. Okay, perbezaan dekat sini untuk sistem open loop tak ada sensor. Kat sini kita ada measurement lah. Okay, measurement yang dilakukan oleh sensor pelampung. Okay, ni another example. So we need to know input dekat sini adalah water level tadilah, output adalah current level, controller adalah operator daripada mata, actuator adalah valve, sensor adalah mata tadilah, dan proses berlaku dekat valve ataupun hand. Okay, so this is element of control system. Okay, positive feedback dan negative feedback tadilah. Okay, right. Another example juga sama. Okay, closed loop dan open loop. Okey, bergantung kepada kita punya pemilihan lah yang mana satu kita hendak guna. Okey, ini sama juga robot control system, sama juga elemen dia. Okey, sensor dekat sini adalah vision daripada kamera. Okey, elemen yang sama. Temperature control system pun sama juga. Okay. So, okay. Next, kita nak, sekiranya kita ingin membuat modeling ataupun simulation. Jadi kita kena memilih sama ada kita punya modeling tu kompleks ataupun less kompleks. Kalau kompleks, dia akan mengambil kira semua faktor dan pengiraannya lebih accurate lah. Okay, example kat sini, sekiranya kita nak buat modeling dalam melihat pergerakan, pattern pergerakan working of human gait. Okay, modeling sudah masuk. Okay, okay, so model simplified representation of reality. So you can see this is a static model simulation. Kita boleh nampak pergerakan dia. Model can be alive, lifeless. Model kita boleh model menggunakan 3D printer untuk melihat mekanisme dia. Okay, this is our prospective area dalam bidang motion capture, material, product dan seterusnya, di teknologi development. Ini adalah produk yang kami hasilkan dekat makmal kami, di mana kami membuat customize make untuk melihat pergerakan pattern kaki tikus lah, untuk membezakan characterize how they working at normal and abnormal. Okay, this is our product penyidikan. Okay, I think that's all. Thank you very much.
Ya, oke, terima kasih. Tepuk tangan dulu untuk Dr. Azmi. Okay, thank you very much, Dr. Azmi, for your presentation. Now, we will open question for all participant students here, and we will discuss with Dr. Azmi. Okay, if you have a question, please raise your hand. Okay, maybe we have 15 minutes for a Q&A. Okay, first, okay, please mention your name and please give a question.
Good afternoon, Mr. My name is Muhammad Rafi. I have one question. Now is the era of digitalization in the industrial world. I have one question about thermodynamic after era digitalization. Is it still being used in industry? As an example, industry automotive or electric vehicle? Thank you.
Maybe his question, the application thermodynamics for in this era, industrial 4.0, which means the main point of thermodynamic application for vehicles and
electric vehicle.
Electrical vehicles, for the electrical vehicles. What is the application of the thermodynamic in the electrical vehicles in this era of industrial 4.0? Maybe it's like autonomous robot or autonomous car, maybe.
Do you mean thermodynamic in autonomous car? What do you mean?
Rafi, please clear your question. What is your point questions?
Thermodynamic still being used in industry of industry automotive or electric vehicle?
Yes, it is the in research. So if you can see, nowadays we have Internet of Things.
Internet of Things.
So the sensor from, for example, heater or cooling, they can monitor the sensor. So you can mobilely monitor the sensor from a distance. I think it's very processing in research nowadays.
Yeah, Dr. Azmi, can I add
Yeah.
to clear? And if you use Internet of Things devices to deploy in your plan, maybe, and then how we can use or monitor the heat transfer, for example. Yeah, this is maybe you can read more about what is the application thermodynamic in the control engineering. Can you be clear for this answer? Okay, maybe.
Thank you.
Okay, others. Okay. Okay, please.
Okay, thanks for the time. My name is Muhammad Randy Pratama. If I heard or learn about thermodynamics, I remember about power plant. As we all know, the priority in Indonesian power plant is coal power plant. And coal power plant include calor, thermal, and thermodynamic system. So, but coal power plant have a bad impact in environment. So I want to ask how Malaysia can minimize the bad impact, or what biomass project research in Universiti Teknologi Mara. And the second one is I want to ask about garbage control system. I curious how Malaysia can control the garbage with control engineering. Thank you.
Okay, thank you for a good question. Okay, actually, in our university, we focus on solar energy.
Solar.
Solar.
Yeah, PV. Like PV.
PV.
Yeah, PV.
Yeah. So we develop solar pump late to harvest the energy from the solar. So it's not my area actually. So my research interest more on robotics rehabilitation. I less doing the thermodynamic application. Sorry, I don't know the application in Indonesia and Malaysia.
Okay.
Sorry, I less information about that.
Okay.
Okay.
Okay, thank you. Okay, it's clear for you.
Okay, thank you. So in Malaysia, is sering. In Malaysia often use solar system for power plant or what?
I think in my university is more on solar energy, not a power plant.
Okay.
Okay. Thank you, Mr. Yes,
Okay.
clear.
Thank you. Okay. You want? Last one. Any other question? Okay. One question. Please. Okay. Mention your name. Okay.
So thanks for the change before. Let me introduce myself. I am Radhy Solihin. So I just confused about the laws of the thermodynamic that you said before. So in the zeros law, it's which mean the temperature to system in equilibrium. And you said that the equilibrium is the state of balance. And as we know, the zero laws is identical with the temperature, right? So is it mean if there are two objects and have the other system in the both of the object with the different temperature. So is it mean that the temperature will be same at the time? And also I think it have connection to the second laws. Is it same with the second laws? That is, in the second laws, in the second second thermodynamic laws is identical with the thermal. And I think thermal is identical with the temperature, right? How the process of the temperature moving in the one object to the other object in the equilibrium, is it same with the in the second laws? I mean, in the second laws, you said that in the hot thermal to the cold thermal. So what is the difference of both? Is it have a connection or what? Thank you.
Thank you very much. Okay, actually, Zero's law reflect to the temperature. Okay, for example here, temperature A equal to temperature B. Okay, so A and B is equal, and then C and B are equal. So we can conclude that A and C is equal. That means the equilibrium, thermal equilibrium between A and C adalah sama. Sama juga yang ni. So bila kita guna sensor yang sama untuk measure, so bacaan dia akan dapat lebih kurang sama. Okay, maksudnya sistem A dengan sistem B dalam keadaan thermal equilibrium lah. Okay, manakala yang kedua tadi, kedua melibatkan heat flow daripada objek panas kepada objek sejuk. Okay, heat transfer melibatkan daripada panas ke sejuk, bukan daripada sejuk ke panas. Okay, itu perbezaan dia lah. Okay.
Thank you.
Okay. Oke, karena waktu udah lewat jam 3, maybe we stop the question, Pak. Oke, now kita sudah mendengarkan ya penjelasan dari Pak Dr. Azmi mengenai aplikasi termodinamika dan kontrol sistemnya. Ya, tadi kita sudah mendengarkan about what we listen to about the system, surroundings, boundary, and then kemudian pembagian what the thermodynamica system thermodynamica consists of the macroscopic and microscopic, and then the type of the system including isolated system, open system, and closed system. Jadi maksudnya yang paling mendasar di sini adalah termodinamika itu you have to know about the physical parameter, how you can calculate the transfer energy and the heat of transfer. Jadi itu merupakan it is the basic knowledge about the thermodynamics. And then what is the correlated between thermodynamic and control engineering? Jadi control engineering itu basicnya adalah matematika. Jadi to manipulate the physical variable, you have to know, you have to learn mathematics. This is the basic of knowledge, mathematics and physics. Physics refer to thermodynamics, and mathematics refers to control engineering. Oke, baik. That's all for today ya Pak. Mungkin kita bisa akhiri untuk webinar hari ini. Saya kembalikan ke MC. Silakan MC.
Thank you for our moderator, Mr. Radhy, for your time, and big thank you for for our speakers, Mr. Muhammad Nur Azmi bin Patar, for the excellent presentation. And also thank you for all participants for paying close attention to this quiz lecture material. And then okay, for Mr. Muhammad Nur Azmi bin Patar, today we have some special gift for you. There is some vendor and also certificate. Please. Okay, thanks to God, we achieve in the end of our event. Hopefully the knowledge gained today will benefit for your future. And next we will have before we have a group photo session, we invite you to fill our attendance and feedback that we will share it into group or scan in the barcode. We will share the barcode to you. Maybe we will give you 3 minutes to fill the attendance. Okay, I think all of you is already done to fill the attendance. So now we will have a photo session.
Maybe the cameraman take a picture together.
Please, can you look at in your behind? come to the forward, please.
Okay, I will count until 3. Please. Okay. 1, 2, 3. Again. 1, 2, 3. Maybe the other focus. Vocational. Vocational science. 1, 2, 3. Again. 1, 2, 3. Okay. Please a big applause.
And for the participant in the Zoom meeting, please turn on your camera.
I would like to say thank you to all the participants for attending this guest lecture from beginning to the end. We apologize for any mistakes in words or action. In closing, thank you all and peace be upon of you. Assalamualaikum warahmatullahi wabarakatuh.